Welcome back. Let's continue now with a few more join examples from the Facebook database. We have already done a good number of examples in the IMDb database. We'll now use Facebook mainly to get you comfortable using the entity relationship diagram of the database to identify the tables that you need for a join. The first query that we'll try to answer is the following. List the profile entries of all the single students. How can we answer this query? Let's take a look at the ER diagram of the Facebook database, and we see that the main table is profiles with quite a few attributes. However, among these attributes, there is no attribute indicating whether a student is single or not. This information is stored in a separate table, the relationship table. So now, to answer this query, we need to join profiles and relationship. The common attribute that these two tables have is profile ID, so we go and write select star from profile P, inner join relationship R on P.profile ID is equal to R.profile ID. We execute this query and you will see that we get back all the attributes from the profiles table, and at the end we have the columns that are coming from the relationship table that contain the profile ID for the student and the status. So now we want to limit our results only to students that are single. So what we do, we go and we add the condition where r.status is equal to single. We execute the query again, and if you scroll to the right, you will see that the columns that are coming from the relationship table, profile ID and status, the status always contains the value single. Now we have the list of all the students that declared their relationship status as single in the database. Let's continue to our next query. We want to find all the single students that live in Palladium according to the residence attribute. Let's start with the easy part. Finding the single students, well, we already have the query. Now what we want to do is we want to extend the query to find the single students who live in Palladium. If you take a look at the residence column, you will see that when people writing where they live, they don't just write Palladium. Some of them write only the name of their dorm. Others also write the room where they live in, and so on. How can we deal with this type of entries? Remember the approximate queries? We are going to use an approximate query here and use the like operator. So we use the where clause where we write where p.residence like and then Palladium and then percentile. So now with this query we get people that are single, and if you check the residence you will see that we have the residence values to be Palladium, sometimes Palladium plus the room number, and so on. And you'll see that we have 284 students that are single and live in Palladium. Let's do one more query. We want to list all the single students who are looking for random play. Let's see first which tables we need for this query. When we're looking for single students, we use the tables relationship and profiles. Now we need to find where the looking for information is stored to find people who are looking for random play. If you check the entity relationship diagram, you will see that we have the looking for table. So let's take a quick look of what is in there. So we type select star from looking for, and you'll see that we have the profile ID of the student and an attribute for what they are looking for. It is a one-to-many relationship, so some profile IDs are assigned multiple looking for values. You can see, for example, friendship, dating, a relationship. For example, a user here is looking for friendship, dating, a relationship. Others are looking just for friendship, others for friendship and dating, random play, or whatever I can get, and so on. We are trying to get this information about what students are looking for and fold it in the prior query which listed the single students. So to achieve that, we're going to add an extra join. So we go to the query, select star from profile P, inner join relationship R on P profile ID equal to R profile ID. And now we add inner join looking for, let's call this L, on L dot profile ID equal to P dot profile ID, and we leave the where part intact for now. This change adds columns from the table looking for into the query. Using the information from this table now, we want to limit our results only to people that are looking for random play. So now we go to the where part and we add the condition, and L dot looking for is equal to random play. We execute now this query and we get back the students that are single and looking for random play. Let's limit the attributes. We need only their instant messenger ID and their gender, and then we let them communicate with each other. So the two attributes that we need, aim and sex, are in the profiles table that has the alias P. So we write select p.aim, p.sex. We execute and you can see that we have the red giraffe bot who is male, and we can talk with Quickstep 1001 who is female, and so on. So they can set up their dates and talk to each other over instant messenger. You'll see also that we have a few people that don't have instant messenger attribute declared. So let's eliminate these people from our results. So we go to the where part and p.aim is not null. So we eliminate all the null values from the results. And now our query is ready and we have the basis for a new Tinder. Now let's move on to a different query. We want to list all the students who have listed Killers as their favorite music. What tables do we need for that? Of course, we need the details for the students, which is in profiles. We also need the favorite music information, which comes from the favorite music table. So let's start now by focusing on favorite music. So we write select star from favorite music M, where M dot music is equal to the Killers. We execute now and we get back the profile IDs of people that list the Killers as one of their favorite bands. Now we want to get the details of the students, so we are going to join with the profiles table on the profile ID. So we go and add inner join profiles P on p.profile ID is equal to m.profile ID. Finally, what attributes do we want to see? We don't really want to see the attributes from the favorite music anymore, as it is just the profile ID and the favorite music attribute, which is always Killers. Therefore, we're going to show just the attributes from the profiles table. So we change the select part to select p.star. Alternatively, if you want, you can put an even smaller subset of the attributes here. Like that, we wrote a query that shows back a list of the students that like the Killers as a music band. Now, let's do one final query. We want to list all the finance students who like the book 1984. We have now two conditions that we want. A, we want finance students. B, we want them to like the book 1984. How can we get this information? First, to get the finance students, we need to go to the concentration table and limit the results to concentration being finance. Second, we also want people that like the book 1984. Where is this information? It is actually in the favorite books table. Specifically, it is in the book attribute. Now, let's try to write this query. We first add the profiles table with the information for the student. So we go select star from profiles P. Next, we need to add the concentration table, which we're going to give it an alias C, and we join on profile ID. So inner join concentration C on p.profile ID is equal to c.profile ID. Also, we want the concentration to be finance, so we go and add the where clause now, where c.concentration is equal to finance. If we execute the query, we get back the students that have declared finance as one of their concentration. Of course, this is not sufficient for what we want. We also want the subset of the finance students who like the book 1984. So we go and we join with the favorite books table as well by adding in the from clause inner join favorite books B on b.profile ID is equal to p.profile ID. Now we have a three-way join with concentration, profile, and favorite books. Finally, now we specify that the favorite book needs to be 1984. So we go and modify the where clause, and we add and b.book is equal to 1984. We execute this query, and you will see that we get now the students that are majoring in finance and list the book 1984 among their favorites. You will see that we have 64 students that satisfy these conditions. I hope that you found these examples on Facebook useful. In contrast to the IMDb database, where the potential joint combinations were rather limited, the Facebook database contains many more tables, and all tables are connected through the shared profile ID key. For such databases, it's useful to be familiar with the entity relationship diagram and know where the information is stored in the database to answer your query. We have reached a very good level for joins at this point. The next few videos in this lesson are focusing on a couple of useful but more advanced concepts: self-joins and outer joins. We're going to get to them, but until then, play around and practice. See you next time.